Hi guys, this is the Innovative Minds Tutor. Hope you're well. Good day to everyone. Right? Since I uploaded my last video on December 2022, but now we are on uh 2023. Hope you will enjoy this video and you will learn. Hope 2023 is treating you well. Even this new year, which is 2023, let's keep winning, guys. Let's keep practicing. Nothing beats practice. Yes, nothing beats practice. The more you practice, the more you seek knowledge, the more success will attract you, right? So without wasting time, in this video, I am going to work with you. We are going to look at Sigma notation. Specifically, we are going to learn how to write the following series in Sigma notation. Yes, we are going to specifically look at these two questions. Very, very important chapter in grade 12, especially in your question 2. You will find patterns, question 2 and 3. Very important, guys. Let's look at the first question. Write the following series in Sigma notation. Right. So the following series here, we are given 2 plus 5 plus 8, blah, blah, blah. What you should note here, we're also given the last term. The last term is denoted by Tn. So let's collect the data first. The first term there, it's given as 2. Then let's see the difference. For us to get to 5, we will add by 3. For us to get to 8, we'll add by 3. So the difference is 3. Okay? So we are specifically going to write this in a sigma notation. Okay? Let's first use a general term so that we know how many terms, the number of terms will be there. Tn plus an minus 1d. Okay, the last term is given as 83. The first term is 2 plus n minus 1, in which we're looking for n. Then d is 3. So let's work this algebraically. So this is 2. Then 3 times n, that's 3n. Negative 1 times 3, that's negative 3. Then we have 83. What we could do is collecting the like terms from here. 2 minus 3 is the same as minus 1. So in other words, we're having 3n minus 1, which is equated to 83. So what we could do is to take negative 1 to the other side. 83 plus 1, that will be 84. Then 3n, right? Remember, we're making n the subject. So how many times does 84 goes into, how many times does 3 goes into 84? Definitely that goes 28 times. So in other words, we have 28 terms, right? We had 28 terms. You mean, what we can notice from the sigma notation, remember, use this symbol here. Here it's a starting point. Our starting point started term 1. So if there was a dot here, that means it will start at T2. But in this case, our starting point started term 1. Then there's a general term that we are going to put here. Our general term, we know, we did calculate it. We get 3n minus 1. So that will be our general term. Then the end point, which is there are 28 terms in this case. Okay, so this is how you can represent this in a sigma notation. Then let's go to the second question. The second question requires us write the series 2 plus 6 plus 12 plus 20 to n terms. Right, okay. First thing first, let's check what type of a pattern is this. All right. We will check by saying, okay, let's check. When I say 6 minus 2, I'll get 4. But when I say 12 minus 6, I'll not get 4. So that means it could be a quadratic. Let's check. 6 minus 2, that is 4. And 12 minus 6, that is 6. What is 20 minus 12? What do we get there? Definitely that's 8. Okay, let's check. Yeah, right. So definitely this is a quadratic. There's a first difference, then there's a second difference. So we have 6 minus 4, which is 2, and 8 minus 6, which is 2. So the second difference. So in other words, we have 2a here. We have the first difference as 3a plus b denoted, and we have this as a plus b, the first term, plus c. Right. So we need to look for the general term. In this case, 2a will be equals to 2, which is the second difference. Then divide both sides by 2. Divide both sides by 2. A is equals to 1. Then let's look for b. Then remember, we're using this formula, 3a plus b is equals to 4. Where there's a, we are going to substitute 1. Then 3 times 1 is 3. Then if you take 3 to the other side, we're going to have 4 minus 3, which is 1. Definitely b to 1. So let's look at c. Then we know a plus b plus c, which is equated to 2. That's 2. That's the first difference, right? So what is our a? Our a is 1. What is b? B is 1. Then what is c? C, we don't know. Then what we could do is 1 plus 1, which is 2, plus c. Then if we take 2 to the other side, it's the same as having 2 minus 2, which will be 0. So let's look at the general term there. Then we have tn is equals to an squared plus bn plus c. What is a? It's 1 squared. 1 n squared is going to be 1. Then b, 1 times n is going to be n. Then c, we don't know. Yes, we have n squared plus n. Even if you can substitute the first term, you're going to have 1 squared plus 1. That will give you 2. Similarly, to get the second term to prove, you will get 6. Right, this is 100% correct, the general term. So let's see. What we don't know, it's a number of terms that will be here at the end point or at the last term. So they said we are having 2 n terms. So the last term here, it's n terms. So what we could have, we should put n here. Then we are going to put the general term, which is n squared plus n. Okay. Then the starting point will be our pattern start at our series start at term 1, right? So in other words, we are going to place n as 1 in this case. So that's how you can work out that's how you can write series in sigma notation. Hope you find this video useful, and don't forget to like the video and subscribe. Let's grow the channel so that we have quality videos. Don't forget to comment and like and share. Sharing is caring. Well, we are on about 200 and something subscribers. We are approaching 300. Let's remember, our goal is to get to 1K, and from 1K we grow the community. Keep sharing, and remember, we love you.